Welcome to Chapter 2, Section 1, Orthogonality, or as your book calls it, Perpendicularity. In this section, we're going to realize how important it is to be concise and clear in our proofs. We're also going to understand this concept of perpendicularity. Now, in your algebra experience, you have learned the definition of perpendicular lines to be two lines that have opposite reciprocal slopes, which that's still true in geometry. However, we're going to focus on another aspect of perpendicular lines, and we're going to look at the way they intersect and the angle they make when they intersect. And perpendicular lines, if two lines are perpendicular, then they intersect to form right angles or 90-degree angles. And notice we can also say the converse of that statement. If two lines intersect to form right angles, then they are perpendicular. Now we can interchange 90 degrees or right angles in both of these definitions. And this is a definition because remember, this is reversible here. Since we can reverse this, it's a definition. Okay, now this is important, very important. Make a big note of this. We cannot assume orthogonality from a diagram. We can assume straight angles. We can assume that points are collinear, but we cannot assume that two lines are perpendicular because we can't assume right angles. Now, if we're told that we have right angles from this form of the definition here, we can then state that two lines are perpendicular, but we have to know more information. We can't just assume. So let's take a look at an example. So first off, this symbol right here, in case you haven't seen it, this upside down T, that is the symbol for perpendicularity or orthogonality. So when we're given that AB is perpendicular to BC, we can say that right away this angle right here is a right angle. And if DC is perpendicular to BC, well then that angle has to be a right angle. So if we want to give a proof here, let's make our two columns for our statements and our reasons. And our first statement is just going to be our given. AB perpendicular to BC. And we can state that because it was given to us. Our second step, our second step is our other piece of given information, that DC is perpendicular to BC. And what can we conclude from that? Well, we can conclude what we just did on our diagram. We just drew that angle B is a right angle. And why can we say that? And we can say that because if, now notice how I write this, if perp, then right. Now, this is the shortened version of our definition, but I'm okay with this. If perpendicular, then right. Okay, so we know if we have a perpendicular lines, then we have right angles. If you want to throw in an angle sign there, by all means, more power to you, but it's not necessary. Well, by the same reasoning, we can say angle C is a right angle. And for step 4, we can just say same as 3. Or if we want to write it out again, we can. It's up to you. And now we can jump right to our conclusion that angle B is congruent to angle C. Why can we say that? Well, we know that B is a right angle, C is a right angle, and we know the very first theorem, if two angles are right, then they are congruent. So right there in 5 steps, we were given 2 pieces of information. We proved 2 angles congruent by using our new definition of perpendicularity and using the first theorem we were given in that right angles are congruent. Okay, let's take a look at this next example. If we're given that EH is perpendicular to HG, now let's digest this information here a little bit. EH is perpendicular to HG. What angles can you prove to be right? Well, I know immediately, most of you are probably looking down here at F, saying, wow, that really looks perpendicular. Okay, it may look perpendicular, but we are told nothing about F. We're only told that EH and HG are perpendicular, so we can only prove that angle EH is right. That is it. This angle right here. Now, if you want to write it as angle GHE, that's fine, but we're still talking about the same angle. That's the only angle we know for a fact is a right angle. As much as EFH and GFH look like they might be right, we don't know. And we need more information for us to be able to conclude that they are right angles. Okay, let's take a look at another one. We're given that KJ is perpendicular to KM. So right away, KJ perpendicular to KM, this angle JKM is a 90-degree angle. That's our immediate conclusion. We see perpendicular lines, perpendicular rays, perpendicular segments. Right away, our brain should be saying right angle, 90 degrees. All right, well, we know that JKO is 4 times as large as MKO. So this is 4 times as large as this. So let's call this X, and let's call this 4X. All right, because if that's some unknown measure, this is 4 times as big as that. Well, what do we know about those two angles? We know that the sum has to be 90 degrees because angle JKM is 90 degrees. So 4X plus X has to equal 90. So 5X equals 90. And what does X equal? Well, X is 90 divided by 5, which is 18. So we know that this is 18 degrees. So that makes this 72 degrees. And double check, do they add up to 90? 72 plus 18, yep, equals 90, okay. And so our two answers, we were supposed to find JKO, 72 degrees. Supposed to find MKO, 18 degrees. We're good to go. Now, what I want you to do before class on Monday, I want you to try page 63, 2 to 4, 7, 8, and 10. Just give these problems a shot here. A couple problems like the examples we did, some proofs. Okay, get those done, ready for class on Monday. When you come in on Monday, we're going to go over these problems, go over a couple more practice problems, and then we're going to move on to section 2. Okay, think of any questions you might have with this section as well. Write those down, make a note of it. Be prepared to ask them in class. Have fun and good luck.